Okay, so next we're going to speak about the configuration part. We're going to do static NAT and static path on the iOS. So first of all, we have to define interfaces as inside and outside NAT. Of course, one interface cannot be both inside and outside at the same time. We have to configure the static NAT rules then, or configure the static path rules, and pretty much that's it. Verification wise, we verify NAT interface configuration and NAT type configuration. So what is the inside outside NAT interfaces and what kind of NAT configuration have I done, static or dynamic, via show IP NAT statistics, and we verify the translation table entries via show IP NAT translation. So looking at our diagram in here, I'm going to make use of this one. Initially, let's do a static NAT. So let's consider that this PC in here. So we're going to see that this is our company as I stated. So whatever it's above router 1 is going to be the internet, which means we're going to configure this interface to be our inside NAT interface, and this interface facing the internet to be our outside NAT interface. So inside and outside NAT. And then what we're going to do is we're going to consider that PCA runs a service. Let's say it is going to run a FTP service. Let me go to PCA real fast and see if I have anything configured on PCA in there to make use of it, like any kind of service which I can start. There you go, it's going to be a TFTP server. Let's make sure I can start a service. TFTP server. It's all good. So let's assume that this PCA runs a TFTP service, which I want that to be publicly available, TFTP. So PCA is an address of 10.10.11.100. And what I'm going to do is, this being my inside NAT interface and this being my outside NAT interface, I'm going to first do a one-to-one binding. And I'm going to make this 10.10.10.11 to be visible on the outside as an IP from VLAN 31. It's going to be visible as 136.1.31.100. So I'm going to do a static translation of 10.10.11.100 to 136.1.31.100. It's going to be one-to-one binding. So let's go in first on router 1, define the interfaces as NAT inside outside, router 1 IP NAT inside, interface gig00, IP NAT inside, then interface gig01 IP NAT outside, IP NAT outside. So if we say show IP NAT statistics, I should see what is my inside NAT being gig00, the LAN interface, and outside NAT gig01, the internet facing interface. And now, if you remember, I stated that NAT was designed to do source NAT. So back in the days, we designed NAT to NAT the source addresses, to NAT the private IP addresses, to provide internet access. It means that it is going to make sense the command, which as traffic is being sourced, let's say from PCA, source from 10.10.11.100, and as that traffic gets routed out on the outside, the source changes to 136.1.31.100. So the command on router 1 is going to be very simple and obvious. It's going to be IP from IPv4 NAT inside, because I get the traffic, I'm netting something from the inside, correct? I'm doing inside NAT because this real address is facing my inside NAT interface. So I'm saying IP NAT inside. So I'm netting something from the inside. And how am I netting that? Source static. I'm netting the source of the IP packet statically. And then what is the source of the IP? 10.10.11.100. And into what am I netting that? Into 136.131.100. So the command makes a lot of sense. So that's going to be the NAT configuration. So going on router 1, we say IP NAT inside source static. So I'm doing an IPv4 NAT for an inside host, and I'm netting that source of statically, and the router receives the traffic with 10.10.11.100, and I want him to net it into 136.1.31 in that VLAN that 100. So if we say show IP NAT translate, show IP NAT statistics, show IP NAT statistics, I see that I have one static translation active. So show IP NAT statistics is not a very good command to verify your NAT configuration. Unfortunately, a lot of the times you should go actually to say show run section IP NAT to verify what I've configured NAT wise, because there's no one good command to verify that. Of course, in my case, seeing the NAT inside outside interfaces and having known that's a static NAT, I have a static NAT configured, I can just say instead of show IP run, I can say show IP NAT translations, and I'm going to see the entry in there. And as you can see, the inside local is the real address, because this address is an address reachable on the inside as visible on the inside on the local LAN. And then as that address gets translated, that's still an address from the inside, but is visible on the global, which means on the outside, because it got translated. So because it's a static NAT entry, it means that if I go on PCA and initiate a telnet session to router 3, I'm going to match on that translation, and I'm going to get netted. Let's go to PCA and telnet to router 3's loopback. Let's go to PCA and say telnet to router 3's loopback. Let's make sure that router 3 doesn't have that management feature enabled. Show control plane, show management interface, not configured. Let's make sure, let's verify if router 1 has a route for the loopback of router 3. So let's confirm routing. So step by step. It does have a route, and it can also, it should be able to also telnet connection refused by remote host. Let's see why on router 3. So no management interface configured. Show run section line VTI. I think on the live VTIs I have configured transport input to be only SSH. Let's fix that up and also allow telnet. So router 1 should be able to telnet to router 3, CISCO. Well, let's make sure that router 3 has a username locally configured. What was the username? SSH user SSH password. Okay, so let's put a username of CISCO to keep things simple. Username CISCO. password CISCO, privilege 15, let's say, password CISCO. And let's send it from router 1. Let's say Cisco, and I got connected. Let's say exit. Now let's try again to turn from router 1 to router 3, and as traffic flows to router 1 from PCA to router 3, and as traffic flows to router 1, PCA's address should get added as configured. Let's try again. There we go. Cisco. And if we say who, as you can see, the real address of PCA is not shown, but the translated address of PCA is connected. Because if you go on router 1 and you say show IP NAT translation, there we go, a translation has happened. As traffic this entry identifies the configured static entry. It's called the simple translation entry. This entry is called the extended translation entry, which means it identifies the traffic flow. So traffic from router 1 with a source random port number, as traffic went inside, outside it was translated to 136.131.100 on that source port number, and destination was not changed because I'm not doing destination NAT. So outside local and outside global have the same values because I'm not doing destination NAT in there. Okay. Now because this is static NAT entry, it means that router 3 is going to be able to, for example, it should be able to ping. It should be able to telnet to PCA, but get rejected because PCA doesn't offer telnet services. And it should also be able to send a TFTP session request to PCA if PCA runs the service, because it's a one-to-one static binding. Let's confirm that. So if you go on router 3 and we telnet, of course, to the mapped address of PCA, so now router 3 is going to send a telnet session destined to 136.1.31.100, which is router 1 is going to route traffic to PCA and change the destination back to 10.10.11.100. Session should not work because PCA doesn't want a telnet service, but translation should still happen because PCA is going to reject that session. So let's go on router 1, and for the moment let's clear the translation table. Clear IP NAT translation. It's going to clear only the dynamic translation entries, not the static ones. So that one remained. And now let's go, as I stated, on router 3 and try to telnet to PCA, of course, to the mapped address of PCA. Telnet 136.131.100. I should get a message refused because PCA doesn't run that service, but translation should have been done because the router should have routed the packet. And there we go. So translation was done. Because what happens is that router 3 has sent the packet, router 1 has routed back to PCA, has done the destination NAT, but then PCA, because it doesn't run the services, it has sent a TCP reset back to the source. But router 1 has done a translation because packet was routed by router 1. And it confirms in here that I initiated a session from router 3, random source port number, to router 1 to PCA's global address on port 23, which that destination was mapped to the local address, likewise on port 23. So this confirms that a static translation is available for traffic to be initiated both ways. It's a one-to-one mapping, always active. Now, as I stated, ideally what we're going to do is, if you run on PCA only a TFTP service, you're not going to do a one-to-one IP binding. You're not going to consume one public address for just one service. So if you in here you run a TFTP service, which means that on this host, which is 10.10.11.100, runs a TFTP server, which means UDP port 69. It means that you're going to do a translation now, a static path translation, which you're going to say that 10.10.11.100 on UDP port 69 is reachable on the outside, is visible on the outside as 136.1.31.100 on UDP port 69. So you do a one-to-one socket-to-socket binding, which means you don't do an IP-to-IP binding. So in this use case, it means that PCA is going to be reachable on the outside, from the outside, only for this service. So by doing this configuration and removing the old static NAT, when I'm going to try to telnet from router 3 to PCA, is not going to work, because telnet is going to be on TCP port 23, and this translation is valid only for traffic on UDP port 69. So let's remove the configuration in there and just make the translation valid for the TFTP service. So say IPNAT inside store static UDP 69. So this is the service I'm publishing out on the internet to be visible as that IP address on port 69. So now if you say show IPNAT translation, this is a static path entry, because it's not a one-to-one IP binding as it was in here. It's a service binding for UDP traffic. So I'm telling the router that this IP address, this service 10.10.11.100 on UDP 69 on the inside is visible on the outside as 136.131.169. So it means that now when I'm going to telnet from router 3 from the internet, I'm going to try and telnet to PCA. So telnet to destination of 136 to the mapped address of PCA 136.1.31.100. As router 1 receives that packet, it's going to drop it, because it doesn't have on router 1 this address, this mapped address is available only for UDP port 69 traffic, not for telnet, which uses TCP 23. So now the session should be dropped by router 1 as I try to telnet, and no translation should be formed. Let's go on router 3 and confirm that. It says still connection refused by remote host, but if you go on router 1's table, no translation has been done at all, because router 1 has ignored that session, because this destination is reachable only for UDP port 69, not for TCP port 23, this mapped address. But first thing, I'm going to start a TFTP service in there, and let's say the directory is going to be browse TFTP server. Okay. Server interface, this one. And let's try and copy via TFTP this file, which is named .ini, I think. Tools, folder option. Show hidden, okay. Hide extensions, not. .ini. So let's try now from router 3 to access the TFTP service of PCA and download a file, and that should work. Let's go to router 3 and say copy TFTP. Let's go in here and configure the TFTP server settings. TFTP security should be none, no security, and let's say OK. So let's say copy TFTP from 136.1.31.100, 136.1, 31.100. The file name is going to be tftpd32.ini, tftpd32.ini 200. So it started the transfer. If you go in here on router 1, if you're in the translation table, there we go, a new session showed up. So router 3 has successfully connected to the TFTP service of PCA. If it doesn't work, it's not a problem, but this confirms that it timed out. It confirms that the NAT has worked. TFTPD32. TFTPD.ini. Current directory, I think it's from the directory. There we go. Let's say lab files. Let's try again. Lab files, and then go to TFTP server and say OK. So let's try now to copy again. So the connection succeeds. So it has to do with the settings of the TFTP server. I'm not going to spend time in here. TFTP security none. It still goes, base directory is still the dot. Log viewer. Timeout. Syslog server. Let's go. Let's try one more time. TFTP server. Let's say settings for the server. And TFTP and base directory. I said lab files and TFTP. I don't know why it constantly changes this. And none, and then okay. And let's try again. So the connection works. As I said, we see it here on router 1. Let me do one more test in here. Let me say show run include section IPNAT. Show run section IPNAT. Let's remove this. And let's do a yes. So let's put back the static one-to-one binding. Do show run include IPNAT. So let's do again a static of one-to-one binding, like static NAT. Show IPNAT translation, and it's okay. And let's try and initiate a session again from router 3, the TFTP session. And it worked. And if you go to router 1 and you say translation, you're gonna see in here, and that was the problem. So TFTP, this is something which again, I'm glad this showed up, because this is not this is a thing which very few, let's say, it's a common misconception how TFTP works, because also TFTP has a control plane session and a data plane session. So initially it didn't work because initially I had netted, when I tried to run the TFTP servers, I have netted PCA's address of 10.10.11.100 into 136.1.31.100. Only for UDP port 69 I was using the static pad functionality, only for UDP port 69, which what this allowed for, this configuration allowed for the control plane session to be built, because TFTP runs on port 69. So router 3, as we saw, was able to connect on UDP port 69 to PCA. That was the control plane session. But then when the transfer plane session was about to start, it didn't work because PCA was available. PCA's address of 10.10.10 of 136, that public address of 136.131.100 was mapped to PCA only for UDP port 69, only for the control plane session of TFTP, not for the data plane session of TFTP. So once I have redone the one-to-one mapping to be the binding to be a static NAT, which means a one-to-one binding, it means that all traffic of PCA, so PCA is going to be known as that mapped address for all IP traffic, which this allowed also for the data plane session to work, which that's what we saw. Because if you can translation table, now that it worked, as you can see, this is the control plane session. It's initiated by router tree with a random source port number and destined to PCA on port 69. But then this is the data plane session, the TFTP transfer session, which, as you can see, it's sourced from router tree, that the same pretty much random source port number, but is destined to the TFTP server likewise on the random port number. Because what happens is that when the router tree, and this is by TFTP design, this is my TFTP server PCA, my TFTP server, and this is my TFTP client. So when they start the control plane session, the server is going to tell the client, on which port should the client start the transfer plane session. So if the control plane session is with a source port of random, destination port of 69, because the TFTP server listens on port 69, then the data plane session, the transfer part, has a source port of random and a destination port of random. And this port is being known to the client from the control plane negotiation with the server. That's what we see in here. And it makes sense that the control plane session was working when I had static path, but then transfer was failing because that address of the server was not reachable also for other port numbers for the data plane session to work.